computing experience here at UNAM. I hope everybody got the slides, and Nick is sending them around now, also on the video link. First, a few words about the UNAM. It's the biggest university in Mexico and actually in all of Ibero-America, which is Latin America plus the Iberian Peninsula, with over 300,000 students, over 35,000 academics, and it produces about 35% of the all academic scientific output in Mexico. In the UNAM we have computing careers in 2 faculties and some other smaller schools and a master's and PhD in computing and special training in supercomputing with a centralized supercomputing service, which as in other places tends to give service exclusive to the university because it's basically overbooked, but there are also clusters and institutes and faculties. To go towards grid projects, which is the thing which I think we're interested here, there have been some local experiments trying to understand middleware in the very early times. There's a group participating in Pragma, and there's been a Mexican project, Grama, trying to link a couple of Mexican universities together. These were early activities. Then comes a group of activities centered around activities from the European community sponsoring collaboration with Latin America, the Ring Grid, the ELA and the ELA2 projects, and the EPIC, which is where I think most of the recent activities happened, and which also means that our grid activities are right now on grid infrastructure leaning towards the European G-Lite middleware, something which I think doesn't reflect quite the international collaborations we have in Mexico, so we'd like to change this. And there's a new project or ongoing project to link 3 of the major computing centers of 3 universities, the UNAM, the UAM, which is another university, and the Investaf, which is a research branch of the Polytechnic University, together in the spirit of having a big shared supercomputing setup. Our interest is to provide production service for existing users. We have, especially in the high energy physics community, users that need grid of production service, but we also want to expand our knowledge of middleware in general. As I mentioned before, we are right now G-Lite centered, and this is where our production resources go into. But given the fact that a lot of the research groups in Mexico have collaborations also with the Pacific Rim, while we're here, with the US, there's an interest in understanding more how to get open science grid and general global space applications running to expand our activities there. And we want to attract more users and applications to the grid structure. I think we're too narrow right now. So we're really interested in both new scientific projects on grid to stimulate the researchers here, and on working on grid computing as a research topic, which doesn't happen much. Most of the time, most of the projects, the technology gets imported from outside into Mexico and gets then run here. We have a couple of activities sponsored around ELA. We have a certification authority, so the UNAM is operating the central certification authority for the PKI, which is open to all communities in Mexico. We have recently set up a joint research unit, which is an organization necessary for required by the European community for that kind of computing infrastructure project, which has been recognized by the National Research Council and is a basis which allowed us to integrate more of the Mexican universities together into bringing people who are interested in Mexico and grid together and integrating them in the ELA project in particular and setting up the next generation of structure. We've also recently become part of a regional operating center for grid in Latin America, which was an initiative for the HEP applications, but it's open to other communities. It's integrated now as an operating center in the EDGI and future European Grid Initiative projects, and it's a collaboration between Mexican, Brazilian, and Colombian computing institutions, and it's a nice example of an integration of technology within the region. Most of the time, we have bilateral collaborations where one of the countries in Latin America works with one of the stronger partners in either the US or Europe. Here, we actually see several Latin American universities pulling things together in a technological computing science-oriented project. To show you the infrastructure, I think I just go through the sites without much detail. We have in the HESCA, which is the Central Computing Service, a small cluster. The Nuclear Science Institute has a cluster which has been set up mainly oriented towards the particle and astroparticle physics. Interest mainly Alice Auger. In future will be the Hawk experiment. Bioinformatics, which is at this point more centered around the interest of their computing staff. We're still trying to activate the researchers in that area. The FES Quartet LAN, which is one of the faculties active, which has a small cluster but is interested in instrumentation over grid, which makes it a very attractive partner for us. So in summary, we have about 60 CPUs and about 1.5 terabyte storage in this infrastructure for general use. And additional by the big experiment, Alice and Auger, another 30 terabyte, which isn't shared with all the rest of the centers and applications. But we've been able to be in stable production for some years now, and to be a center of production for Alice and Auger. And at this point, we're starting to get interest from other institutions within the UNAM, especially astronomy and physics. There's applications, as I mentioned, we have, which was one of the initial driving forces for going into this grid development with G-LIGHT, Alice as a heavy ion experiment at CERN. There was a strong interest to have the computing infrastructure, since Mexico contributed 2 of the detectors to Alice, so to be able to do the analysis after we've done part of the construction of the detectors. The Piaget Observatory, which is the world's largest cosmic ray observatory, with a site currently installed in Argentina. Mexico has participated both in the hardware and in the software aspects, including some of the grid optimization of the software, which is currently on its way. One of the bioinformatics applications has been ported from, which is part of the European Molecular Biology Lab software suite, has been ported by a team from the UNAM during one of the ELA grid schools and is now available. There's an application which uses the remote instrumentation over grid on food freezing, trying to share expensive instruments with remote sites. In this case, food freezing is an important industrial project, an industrial process. There's a group starting now, a seismology related project between one of the applied branches of the Physics Institute, or one of the applied physics institutes in the UNAM, trying to access remote sensors of the sensor network in Mexico and do some real-time processing of the data. This is an application still in its infancy. It probably can benefit from collaborators of people who have experience with seismology applications in a grid environment, and I'm sure that the colleagues will be very interested in anybody who can offer either interest or collaboration and help. Upcoming, which will be the next driving force in terms of size, is the HAWK, the High Altitude Water Cherenkov Cosmic Ray Observatory. It's a US-Mexico collaboration with a site actually being in Mexico, which means the primary data center will be hosted at the UNAM. We get about 200 terabytes, sorry for the typo on the slide, per year for 5 years. So it's for Mexico a new scale of actually pushing us into the petabyte scale of data handling. And we're looking at this point in evaluating different grid technologies to do both our data management and the corresponding simulation and data analysis CPU resource management. People have been active in training, especially sponsored through ELA, with some tutorials for users and administrators, but also with a grid school for verification of application right now in October, a school that was, I think, a success that finished about a week ago. We have local experts by now capable of doing the training, and they have participated in other training events in Latin America. So that knowledge and know-how we have. But we face some challenges. I think we show that we can run grid infrastructures and grid services here. Some applications we have could do can use more resources than we have currently available. What is a great problem is that most of the activity in applications is centered around a few groups in the UNAM, and especially pushed by high energy physics and astroparticle physics related groups. So we really want to expand in our community by attracting new applications and maybe provide smaller institutions who don't have centralized big resources with resources through the grid. A limiting factor, which is something typical for developing countries like Mexico, but we've seen this in other Latin American countries, is that the networking infrastructure is a limiting factor. Communications costs are high, and therefore bandwidth is limited, which means resource sharing over a grid in a grid-like environment is sometimes harder than it should be. And what we have to develop and what we need to develop and what we're looking into is that our resource centers can be multiple middleware infrastructure centers. So we can use one center to support collaborations by the researchers independently of whether they have their colleagues in Europe or whether their predominant collaboration is within Latin America towards the US and Canada or with other places in the Pacific Rim. Okay, so that's my quick presentation about what we've been up to in the UNAM. José Luis Gordillo has prepared another presentation which I think has mostly overlap, so we don't think this has to be presented, but it completes the numbers that I've given here in this presentation.
Yep. Okay. I think we have to stop here. Okay. Thank you very much. Thank you.